Unit 5, Day 2. Again, test on Thursday over this, and the next page is graphing log. But today's graphing exponents. So the notes aren't really, in terms of like what to do to, here's the instructions and then we'll work some examples together. Make a table of values. Like when in doubt, that's always a good strategy for graphing. If you don't know what something looks like, make a table of values. And basically you make a table of values big enough until you understand what the graph looks like. But the smart way to make a table of values for exponents, so this is like the only sort of notes part of the, I mean all of its notes, but this is the new information part. Pick x values, so the exponent is -1, 0, and 1. So we're going to pick our x values so that the exponent becomes -1, 0, and 1.
You can't do
No.
0 in an exponent, right?
You can do a 0 in an exponent.
Oh, I thought if it was 0, it would be 1.
So for this one, if y equals 4 to the x, then the exponent is x, and so we'll use -1, 0, and 1.
Okay.
So what's 4 to the -1?
Negative,
Yeah, careful, not negative.
no,
1/4. And what's 4 to the 0?
1,
And then our favorite, what's 4 to the first?
4.
4. So let's plot those 3 points. So -1, 1/4. That's kind of tricky to get when your graph is already kind of small. 0, 1, 1, 4. Now, for this first graph only, because maybe we don't know exactly what's going on, let's also graph 2 and -2 for x, just to see what else is happening. After we know the shape, we'll only graph the 3 key points. But first one, let's make sure what's going on. So if I plug in 2, what's 4 squared? 16. So 2 comma 16 is like way up there. You can put it on there if you want. But it's way off the graph. How about at x equals 3? If we went one more, what's big number?
It'd be 64.
64. So that's way, way off the graph. All right, how about 4 to the -2? What would that be? 1 what? 4 squared is 1/16. Although the difference between 1/8 and 1/16 on this graph would be,
Nothing.
you couldn't tell, yeah. What would the next point over be if we plugged in -3?
164.
1/64. And then you're practically on top of the x-axis,
You'd have to zoom out.
which means what's going on there?
There's an asymptote.
There's an asymptote. So it's a pretty steep curve there, and there is an asymptote there. Number 2, x and y. Okay, this is where things get a little interesting because it's not just an x up there, it's x minus 2. There's sort of 2 ways to handle this. So one way is to go like parent function thing, and that says I'm going to go right 2. There's nothing wrong with that, but if you want to use that method, that means you have to know the first graph really well in order to be able to shift it to the right 2. And I don't know. So here's my method of shifting to the right 2. We always want our exponent to be -1, 0, and 1. So what value of x should I pick so that my exponent is -1?
1, 2, and 3.
Yeah, well, 1 for this one. And if I want my exponent to be 0,
2.
x should be 2. And if I want my exponent to be 1, x should be 3. And then my y values will be with the same they were over there, because I'll have 4 to the -1, 4 to the 0, and 4 to the first. And what that accomplished is shifting it to the right too. So if you can shift it to the right too without a table, that's fine, but you would probably have to start with with this table anyway. Now when you go to the graph, make sure don't use the exponent, right? It's not one of our axes, it's exponent. Our axes are x and y, so make sure you're switching back to 1, 1/4, 2, 1, 3, 4. And sure enough, I like to use the parent function thing as a check at the end. This was supposed to move right 2 from the original, and it did.
We need to mark the asymptotes.
You don't. I mean, you need to know it's there, so you better sketch it accordingly, but you don't. We're not going to ask you to identify them. All right, speaking of parent functions, what's the -5 at the end going to do?
The line will be down.
So which coordinate will that change? That'll be the y coordinate. So I can still use -1, 0, and 1. But now they're all just down 5. So 1/4 -5. 1 -5. 4 -5. So you can do the math, or you could kind of just say, well, I'm just going to go down 5 and then up a fourth. 4, 5, up a fourth. Right? Rather than figuring out what that is. I mean, yeah, it's -4 3/4, but why don't you just go down 5 and up a fourth? The others are a little easier. 0, -4. 1, -1. Where's our asymptote on this one?
The 5.
The 5. That number by itself is the y equals asymptote. And you don't have to know that. You can kind of just figure it out, but that makes it a little bit easier if you know that. Number 4, if we're thinking parent functions, what does a negative in front of the x do? It flips it over the y-axis. We don't do that much. So on this one, maybe I switch back to thinking I need my exponent to be -1, 0, and 1. Because that will always work, and that will always make the math kind of easy. So what value of x should I pick to make the exponent be, to make the exponent as -x? If I want -x to equal -1, what should x be? 1. If I plug in x as 1, then my exponent, not the 4, just the exponent stuff, becomes -1. What value of x should I pick to get 0 as the exponent? And then really think hard here. What value of x should I pick so that negative x equals a positive 1? Negative 1. So 4 to the negative 1 is 1/4. 4 to the 0 is 1. 4 to the first is 4. Careful, these are backwards now because of that negative. 1 comma 1/4. 0 comma 1. Negative 1/4. And sure enough, we have a sort of a flipped exponent graph. Number 5, e to the x. Well, it would be real helpful if we knew what e was equal to.
2.7182 something.
Yes.
Yeah. Isn't it like 2.1828? There's like or is it?
It goes forever.
Yeah, it's like pi, but a different.
2.7, it is similar to pi. They're both irrational numbers. 2.7, 1828, 1828. Wait, I wrote something down wrong, but it doesn't really matter. 1828.
There's no extra one.
Now, yeah, I put an extra 1 in there. But when it comes to graphing, how is 2.7 going to look any different than 2.7, 1828, 1828 on a graph this small? Like those are the same thing for a graph this small, right? Like if I zoomed in 100 times, then maybe I could tell the difference. But for this graph, there's not. I mean, it happens to be 1828, 1828 for that set, but after that, it's just.
After that, then it goes.
It's crazy. It's just like pi. It's not random, but it feels random.
That's what E is?
So E is just a number, 2.7, etc., etc., etc. So let's do the same thing. Negative 1, 0, and 1. So e to the negative 1, 1 over 2.7. Actually, that's approximately. Just approximately 1 over 3. Like again, in terms of our graph, that's going to be close enough. How about e to the 0? I bet you can get that one exact. 1. Anything to the 0 is 1. And then e to the first is 2.7. Carry as many decimals as you like because you're not going to be able to graph it any more accurate than 2.7. So negative 1 comma a third, 0 comma 1, and 1 comma 2.7. And again, I can't, if you're between 2 and 3 and a little bit closer to 3 than 2, that's accurate enough. I mean, I'm not going to be like, oh, let me put that under the camera and zoom in. It won't even let me, right? It won't even let me zoom in any further, so I'll just have to trust you that that's 2.7.
So just
So if I make a dot over the entire graphic, you can't tell if it's wrong.
Somewhere in the middle. Then he'll probably count.
you should have us do yours. That was. So it's you know I, right? So it's e to the power of I to the power of pi plus 1 is equal to 1. So it's awful.
Let's see, number 6, I have a negative exponent. We've done this before. If I want my exponent to be negative 1, 0, 1. So the e is, again, yuck, but I'm not worried about that yet. 1, 0, negative 1. So e to the negative 1 is 1/3. Close enough. E to the 0 is 1. E to the first is 2.7. Again, The exponent column is nice to help you figure out what to plug in for x, but don't use that when it comes to graphing, because we want to use x and y only here. 1, 1/3, 0, 1, -1, 2.7. Is that 2.7 better than my last 2.7?
That's a 2.8.
That one's 2.8. -5 for me again. Number 7. What's the +5 going to do?
It's gonna move it to the right, left. No, to the left.
Left 5.
Down 7.
So, I don't know. It might be easier to, I don't know. You can plot points, or if you can take your original points from up here and move them left 5 and down 7, you can do that. Left 5 would be -6, -5, and -4. But that also makes the exponent -1, 0, 1. So you can think of it two different ways. You can either think, well, what do I want my exponent to be? Or you can go back to the original and just say, you know what, I'm going to shift those points left 5. And then down 7, well, that'd be 1/3 -7, 1 -7, and 2.7 -7. So -6, comma, -7, but then up 1/3. Right? I'm not even doing the fraction work. I'm just going to go down 7 and then up 1/3, like sort of doing the math on the graph. Now, when the math's easy, I'll do the math. So I'll go left 5 and down 6. 1, 2, 3, 4, 5, 6. You need to get glasses to do this. -4, and then, well, I can go down 7 and then up 2.7. So if I only graph 3 points, you might think it's a line, but we've graphed a bunch of these by now, and we know what the shape is. -e to the -x. What's that going to do? Flip over the x-axis. Change our y values. So our x values are the same. Our y values are now negative. So -1/3, -1, -2.7. Second page of notes is just some questions to think about, which kind of already have these answered. We just hadn't phrased them like this. I'm going to draw a quick sketch because that'll help me answer these questions. What's the domain of that function? I can plug anything I want in there for x. All real numbers. for the domain. What about the range?
0 infinity.
0 infinity. 0 with the parentheses or 0 with the bracket? Uh-oh.
Parentheses because it never actually touches zero.
Parentheses because it never actually gets there. Gets really close, right? 1 over 64 and 1 over 256 and 1 over whatever, but it never gets to 0.
I was just going to say, like, it would change it to, like, -5, right? Because -5 would be the asymptote.
Now, you're right. If this is specifically for this function. If we had -5 at the end of that, then yes, this would be from -5 to infinity. So that's a good question. Name 3 points. Well, the 3 points are where the x value, that's sort of what we started with, the x value being -1, 0, and 1. So we had 1 over e, or 1 over 2.7, or 1 over 3 even. E to the 0 is 1. And e to the first is e. Or 2.7. Either one. Let's see. X-intercepts. That would be places where it crosses the x-axis.
Yeah, it does.
None. Good. Trick question, but you were not fooled. And again, that would change if our original function got moved down, then it would have an x-intercept, but this one does not. And the y-intercept is right there at 0, 1. So your assignment today is, worksheet looks nearly identical to the notes page with different numbers, some different numbers. So for that first one, you'll definitely need to go -1, 0, 1. After that, since they're all base 3, you can use the parent function thing and adjust your first graph. Or make a whole new table of values. Kind of 2 different ways to go. And then there's more practice with E. And then there's some multiple choice questions about properties of the graphs. Now, again, test creeps up on us quick. Test on this is Thursday, so make sure you do this tonight. Ask questions tomorrow, so you'll be ready to go come Thursday. Keep up the good work on the testing situation in here.